Hi everybody, Professor Jim here. We're working on statistics. We covered measures of central tendency the last two videos. Now we're going to be talking about measures of dispersion. That basically means how spread out are the numbers. Okay. Let your friends know about Professor Jim Rocks Math. Don't be shy. Let your family know. It's open to everybody, 24/7, 365. Anybody who can access YouTube. And I'd just like to give a little shout out to my friends at the Music Den in Randolph, New Jersey, at 1030 1030 Route 10 West for all your musical instrument and lessons needs or wants. Okay, it's a really nice store there, and the people are very friendly, and they have really nice equipment. Okay, all right, anyway, back to dispersion. Okay, how spread out are the numbers? This is what dispersion will tell us when we have numbers. So we're looking at exact numbers that we calculate. Okay, this is a normal curve or the bell curve. So is this. This one's spread out or it's more dispersed. There's more dispersion there. This is called skewed right. Somewhat goes opposite. Skewed right means most of the numbers are on the left. And skewed left means most of the numbers are on the right. And it sounds a little bit backwards. But they've kept it for a long time. Okay, so that's what we're looking at. First, there's three, just like measures of central tendency, three things going on. One is the range, and that's the highest number minus the lowest. Okay, so I just picked numbers. Let's say a professional athlete on a team is making $50 million a year. So that's the highest paid person on the team. Let's say somebody else, the lowest paid person on the team, gets paid $1 million. Still a great amount of money to get paid. All right, so the difference between 50 and 1 million is 49 million. So that's the range. Range is real easy. Highest minus lowest, there's your range. Okay, I'll give an example. You need to calculate variance first. Does variance take a long time to calculate? Depends how many numbers you have. If you have 5 numbers, the answer is no, it doesn't take a long time. If you have 37 numbers or 100 numbers, yes, it takes longer. Can we figure these things out on a PC now? Yes, but you probably won't be using one in class. Okay, anyway, let's do variance first. Yes, there's a mathematical formula for this that looks very confusing. So instead, we're going to do something else. Okay, what we're going to do is take our numbers given, let's say we're picking hockey players. We're going to take 5 numbers, because that won't take long, right? So we're going to pick 5 goal scorers and write down how many goals they had last year. Okay, I'm going to pick numbers. Okay. Then we have the mean. We're going to set up 4 groupings for the variance. Once we get an answer, it'll be real easy figuring out standard deviation. Okay, we're handed a bunch of numbers, in this case goal scorers. Okay, we add up how many goals they score. When you add this up, the total is 200. We remember the mean from the other video, it's the same as an average. We take 200 goals scored, we divide by 5 hockey players, and the average is 40. Okay, next grouping is the numbers given minus the mean. We we just go straight across the row. 50 minus 40 is 10. 5 minus 10. Minus 5 and 0. Have to draw better rows there. Okay, when we add this up, so there's going to be some numbers in the third grouping that are above the mean. There'll be numbers that are below the mean. And in this case, we have a 0 also. 40 minus 40, 0. We add them up, they add up to 0. Okay, that's good. Next column. We take the grouping right before it and we square the numbers. Now the negative numbers are now positive numbers because we have negative times negative is positive. All right, it's 100. Okay, we have a total of 250. That becomes our numerator. Now this is a sample of 5 hockey players. There's more than 5 hockey players on the team. There's more than 5 hockey players in the league, a lot more. Okay, so it's a sample. So when we have a sample, we take how many, in this case, hockey players we have, and subtract 1. Okay, so we divide by 4, we get 62 and a half. That is our variance. Standard deviation equals the square root of our variance. So that's a nice easy formula. We can remember that, just like n plus 1 over 2. Okay, so we take 62.5, put it in a square root sign. Don't know the answer off the top of my head. Do you know the answer off the top of your head? No. All right, we can go look at our calculators, right? And go figure that out. Is mine on? I think it is. Okay. Let's go look for a second. 7.8, something around there. Give or take, see if this thing spins sideways. Maybe it does, maybe it doesn't. Nope. Okay. Can't count on that. All right. So what do we have? Approximately 64, square root of 64 is 8. Square root of 49 is 7. So we have somewhere around 7.8 or 7.9 as a standard deviation. That'll come into play with the mean a lot in statistics. They'll have mean, they'll have standard deviation, they'll have 2 standard deviations, they'll have 3 standard deviations, and they'll have other things in between 0 and 3. But this is one of the other main numbers. Mean, median, standard deviation are 3 of the main definitions for stats. Okay, have a great day, everybody, and please subscribe. Thanks a lot. Take care. Bye.